Not in the future, not hypothetically. Right now, today, Earth is passing through a debris field left behind by an asteroid the Sun is actively tearing apart. A NASA scientist just confirmed it, published in the Astrophysical Journal. Real data, real meteors, real debris. And here is the part that nobody is talking about. We still cannot find the asteroid. It is out there right now, being baked to pieces by the Sun, shedding fragments into space. And we cannot see it. We know it exists only because of what it is leaving behind. Stay with me, because this story is not what the headlines are making it sound like, and it's more alarming than they're letting on. If this is your first time here, this channel covers what is actually happening in space right now and tells you what it means for the planet you're standing on. Real data, real science, real consequences. Hit subscribe. Because what I'm about to walk you through in the next 10 minutes changes how you think about the space around Earth permanently. Let's get into it. Let's start with what was actually discovered. Dr. Patrick Shober, a postdoctoral fellow in planetary sciences at NASA's Johnson Space Center, spent months doing something most people never think about. He went looking for shooting stars that didn't belong. He analyzed 235,271 meteors and fireballs collected by all sky camera networks across Canada, Japan, California, and Europe. Automated cameras running every night, photographing the sky, logging every streak of light that passes through the atmosphere. Most of those meteors are background noise, random space dust, nothing unusual. But inside that data set, buried inside 235,271 observations, Dr. Shober found something that stood out immediately. 282 meteors, all appearing to originate from the exact same point in space. 282 meteors that didn't belong to any known asteroid, any known comet, any known debris stream, a brand new meteor shower, one that nobody had ever cataloged before. And when he traced those 282 meteors backward, followed their trajectory back through the atmosphere, back into space, back along the orbital path they came from, what he found was not a comet. It was an asteroid on an extreme orbit that carries it nearly 5 times closer to the Sun than Earth ever travels. 5 times closer. At that distance, the Sun is not a distant star providing warmth and light. At that distance, the Sun is a furnace, temperatures high enough to crack rock, high enough to bake out trapped gases, high enough to cause the surface of a solid asteroid to fracture and crumble and shed material into space. The asteroid is being destroyed. Right now, actively. The Sun is tearing it apart piece by piece, and the debris it is shedding, the dust, the fragments, the rocky material, is spreading along its orbital path, and Earth's orbit crosses that path, which means right now, Earth is moving through the fallout. Now let me explain what that actually means, because when you read the phrase, flying through debris, your brain goes to a specific place. Rocks hitting the planet, danger, destruction. That is not what is happening. What is happening is this. The debris from this asteroid is tiny. Most of it is the size of a grain of sand, some of it the size of a small pebble. When these fragments hit Earth's atmosphere, moving at over 15 miles per second, they don't reach the ground. They burn up instantly. The outer layer vaporizes, the fragment turns into an electrically charged gas. It glows, briefly, brilliantly, and then it is gone. That is what a shooting star is. That is what a meteor is. A piece of space debris burning up in the atmosphere, never reaching the surface. So Earth flying through this debris field means shooting stars, a new meteor shower, officially designated M2026A1. Not a threat, not a danger. But here is where the story stops being reassuring and starts being something else entirely. The asteroid doing this, the one being torn apart by the sun, we cannot find it. Think about what that means. We have 282 meteors as evidence it exists. We have traced its orbital path. We know it is traveling an extreme orbit that carries it closer to the sun than any planet in our solar system. We know it is actively fragmenting right now. And we cannot see it. Why? Because it is a dark object, rocky, non-reflective, traveling an orbit that keeps it close to the sun, which means when we try to look for it from Earth, we are looking toward the sun. The glare makes it nearly invisible to ground-based telescopes. This is not a unique problem. It is a systemic one. There's an entire population of near-Earth asteroids that travel sun-approaching orbits, objects whose paths carry them deep into the inner solar system where the sun's glare makes them almost impossible to detect. We do not know how many of these objects exist. We do not know their sizes. We do not know their orbital paths. We know about this one only because it is fragmenting, shedding debris, leaving behind a trail that our cameras can detect when it crosses Earth's orbit. A silent asteroid, leaving behind the only evidence of its existence in the form of 282 shooting stars. Now ask yourself, how many asteroids like this are out there that are not fragmenting, that are not shedding debris, that are simply moving through their orbits, dark and silent, completely invisible to us? We don't know. That is the honest answer. We don't know. Let me give you the historical anchor for why this matters. February 15, 2013, Chelyabinsk, Russia. At 9:20 in the morning local time, a fireball appeared in the sky over the southern Ural region, brighter than the sun, moving at 40,000 miles per hour. It was an asteroid approximately 20 meters wide, about the size of a 6-story building, that entered Earth's atmosphere and exploded with the force of roughly 30 Hiroshima bombs. The shock waves shattered windows across 6 cities, damaged over 7,000 buildings, injured 1,500 people, most of them from flying glass. Nobody saw it coming, not a single telescope, not a single tracking system, not a single early warning. And here is the specific reason why. It came from the direction of the sun, the same direction that makes sun-approaching asteroids invisible, the same direction that hides the asteroid currently being destroyed, the one whose debris Earth is passing through right now. The Chelyabinsk asteroid was not on any watch list. It was not in any catalog. It was completely unknown to every planetary defense system on Earth until it was 32 seconds from detonation. And it was only 20 meters wide. The asteroid behind the M2026A1 debris stream, the one we still cannot find, is almost certainly larger than that, because smaller objects fragment more completely. Larger ones shed debris over longer periods. We don't know how large it is. We can't see it clearly enough to measure it. So where does this leave us? NASA knows this detection gap exists. It is known for years. And there is a solution in development. It is called the NEO Surveyor, a dedicated space telescope designed specifically to find dark, sun-approaching asteroids, the objects that ground-based telescopes cannot see because of solar glare. NEO Surveyor would orbit at the L1 Lagrange point between Earth and the Sun, pointing away from the sun, surveying the sky for exactly the kind of object that produced this debris stream. It is expected to dramatically improve our detection of near-Earth objects in sun-approaching orbits. It would find the asteroids we are currently blind to. NEO Surveyor launches in 2027, not today, not this year. Until that telescope is in orbit and operational, the population of dark, sun-approaching asteroids remains largely invisible. The detection gap stays open. Objects like the one currently shedding debris across Earth's orbital path can exist, travel, fragment, and in some cases approach Earth without adequate warning. That gap is not permanent, but it is real, and it is open right now. So let me bring this back to where we started. Right now, Earth is passing through a debris field from an asteroid the sun is actively destroying. The debris is harmless, shooting stars burning up in the atmosphere, nothing reaching the surface. But the asteroid itself, the source of that debris, is invisible to us, traveling an extreme sun-approaching orbit, being torn apart by solar heat, and we will not have the telescope capable of reliably finding objects like it until 2027. That is the real story. Not that Earth is in danger from this specific debris stream. It isn't. The real story is what this discovery reveals about the population of objects we cannot see. The asteroids moving through the inner solar system on sun-approaching orbits, dark and silent, outside the coverage of our current detection systems. Dr. Shober said it directly in his paper. This discovery reveals hidden populations of near-Earth asteroids. It is vital information for planetary defense. 282 shooting stars, one hidden asteroid, one detection gap that stays open until 2027. That is what is happening right now in the space above this planet. And it is only visible at all because the sun is tearing something apart and leaving behind the evidence in the form of light. If you want to follow this story as it develops, if you want to know when NEO Surveyor launches, what it finds, and what the next discovery from the debris streams crossing Earth's orbit looks like, subscribe to Deep Sky Nexus, because this channel will be here every time something real happens in the space above this planet.